Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today I'll be interviewing Nemo Hsiao, who's currently working on his Ph.D. in electrical engineering and computer science at MIT. How are you doing today?
Pretty good. Thanks for having me.
Thanks for coming on the podcast. So to get started, I wanted to ask what made you choose your major while you're still in high school?
I think it goes all the way back to high school where I had a course and where they teach us like how to draw CAD, like 3D model basically. So like there this course like the instructor was just like teaching us how to, let's say draw a cube, draw circles or something like that and putting everything together in the computer. And I eventually drew a mirrorless camera, like 3D model of a mirrorless camera, and then put them together. And that was the time that I feel like, okay, I'm pretty good at with like, things in the 3D space. So that's one of the reasons that I decided to choose like mechanical engineering, because in general, I love like making stuff, like designing stuff, and then building them together. So like that's why I chose mechanical engineering, like when I started at college, basically.
Yeah, so what was your experience like getting your bachelor's degree?
It was pretty cool. I would say I'm like super lucky that I get to study things that I'm like really enjoying. For example, like I just mentioned, like really like building stuff, and mechanical engineering is like exactly the type of subject where you get to like actually build stuff like from scratch. Like you kind of like need to draw your design on a piece of papers and from different perspective. You have like side views, front view, cross-section view, that type of things. And then you will move on to like either 3D print the things that you design, or you kind of like do those like machining. And then eventually you need some like electronics that come into play to help you actually make your stuff like move or like actually function. So I would say I really love this like overall experience, in the sense that like I think it really makes me like happy when I'm like studying this like subject.
Yeah. So during your bachelor's, I saw that you did some exchange programs. What was that like?
So I did like two exchange programs. One was in the Netherlands. It's at a small town called Delft, and the school is called TU Delft. So it's like a really technical oriented like university. And I was like doing aerospace engineering there. It was really cool in the sense that exchange students usually hang out with other exchange students. So I actually got to live with a bunch of like students from across the world. So like I think we have like 8 people living together. When I say like living together, I mean it's like we share the same kitchen, but we still have our own room. And we have people from like Germany, Switzerland, Sweden, Norway, Finland. I'm mostly like Scandinavian country. But also one guy from Florida, and like I'm from like Taiwan. So it was like a really cool mixture. You get to really know people from other backgrounds in your daily life. And back in the days, like we used to do this type of like cultural event like by ourselves. So like I think if I remember correctly, it's like every Sunday night we will get together and then have dinner in the kitchen. And it's like every week, one person will be in charge of the dinner, and you are supposed to make something that is from your hometown. Like there's some like let's say like from for me, I would be making like Taiwanese food to serve like this 8 people, and some other people like the German guy, he would be like serving like the German food. So that was like really cool to experience like different culture and also like get to know people from like different background.
Yeah.
Yeah.
So what made you want to try the exchange program again and come to Georgia Tech?
I think the my experience with my first exchange program, which is at Netherlands, was like super awesome. Like in addition to like the cultural exposure, I also like learned a lot like on the technical contents, like those like engineering stuff. Um, that was great. That was the time that I feel like, oh, okay, whether it's possible to do like a second one so that but like maybe this time I don't really want to do it in Europe anymore, so like I just say maybe I should do it in US or like Canada. And there were like a few schools that were on the list, and I ended up like doing it at Georgia Tech, and that was super cool. That was like my first time actually studying in a university in the US. And the way I think students and professor interacts are a little bit different compared to that in the Netherlands or compared to that in Hong Kong. So it was really cool for me. And I just like always want to try new things basically. So like previously I've experienced like the European style, and now like I get a taste of like how the higher education look like in the US.
Yeah. So, I guess saying that you got to see what higher education was like, is that kind of where you made the decision to get a PhD?
Yeah, yes, I think that's one thing. Like just to see how like the higher education look like. I think the other thing is like throughout my undergrad, I get to do some of the research in some of the research lab. Like I joined a research lab um doing at my home university. I also joined another research lab when I was doing my exchange program in the Netherlands. And that was the time that I feel like, okay, I'm really interested in doing research and like publishing paper, writing paper, those type of things. So that was the time that I feel like, okay, I might actually enjoy doing a PhD or like entering a PhD program.
Yeah. So, what was the process like when you were applying to PhD programs? Like, how many schools were you looking into and all of that?
I would say I'm like kind of like I think I'm just like normal people. I applied to like 12, 15 school. I think one of the biggest difference between like applying for PhD rather than compared to applying to master is that usually when you apply for a PhD program, you actually need to identify a few potential advisor. So what that means is like you need to find a professor or like a few professors who are doing similar research or like who are doing research that you are interested in. So what I did in the past was like I actually go to those like I went to those like their website to see what they are doing. And then probably read a few of their papers and then and sometimes figure out, oh, this is like a professor that is doing something interesting to me. Then I'll be like applying for their lab basically. And I think I ended up applying to 15 universities. Yeah. And then luckily, like MIT was one of the school that accepted me. So yeah.
Yeah. So, what's your experience like been so far at MIT?
Oh, I would say this is one of the best place that I have ever been, to be honest. And then I think especially if it's like for engineering. I don't really know like other discipline, like if you considering like liberal arts or like other discipline, MIT might not be like the best place, but in my opinion, it's like if you're studying engineering, I think MIT is a really good place. Where I think it's there we I can talk about it from different perspective. Like I think the first thing is the professors here are really like they are like well known and well respected scholar in this field. So you can like basically the professor that I interact with like on a daily basis, they might be just the professor that who wrote the textbook, and then some of the textbooks are kind of like the Bible in the field. So it's really cool to like see those people. at the same time, it's like you might just like bump into some Nobel laureate on at the corridor. So that's one thing is like the professors, like the instructors here are like really um, well-respected scholar. I think the second thing is the your colleague or your like classmates or like whoever is like interacting with you, or like all the students at MIT. I think in general, people here, like students here, are like enthusiastic or like really passionate about like what they are doing. I think either it's like toward like the coursework or towards like the research that they are working on. So I think is like willing to spend like extra times on those subjects, like either the course they are taking or like a project they're doing for their research. And in general, I think this is a really collaborative atmosphere in the sense that um, you are basically working with a bunch of like really smart people and really hardworking people, and they are very willing to like share information with you or like teach you something when you don't know, like when you don't understand one of the concept in the class. So I feel like really comfortable like studying or like researching here. It's like you get a lot of support from your colleague, your from all the students here, and also from the professor. And I think the third one is like the facility here at MIT are in general like good. So like you don't really need to worry about like um let's say like in the lab when we try to set up the lab, there are a lot of people like coming to help us set up the equipment and everything. So you have like very little to worry about like outside of your like actual research. So I think these are like the three factors that I would say it's like that make me feel like, oh, I really enjoy MIT here.
Yeah. Can you talk about what your research is about?
Um, so my research is about developing this very tiny flapping wing flying robot. So when I say flat tiny, that means like usually like within a like a circle like this. So it's like 1 inch or like at most like 2 inches. So like it's like super lightweight. Um and it's usually less than 1 gram. So that means it's less than like it's lighter than an American cent, basically. So it's like tiny robot that's like really small, and really tiny. And it can actually fly. So it's like a tiny drone, so I can just like fly up like that. And the way they fly is that it doesn't really use propeller because like most of the commercial drones that you see nowadays they usually use propeller to like spin they spin their propeller basically. But in our case, because this whole thing is so tiny, this whole platform is so tiny, you cannot really put propeller on that. So you actually need to use flapping wing mechanism just like bees or like mosquitoes that you see in nature. So we do like fabricate like this like flapping wing mechanism and put it on the really tiny robot, and then so that it can actually fly. And it's usually flapping around like 300 to 400 hertz, like it fly like 300 to 400 times per second. So when they fly, you can actually hear the bzzz sound of the robot. So yeah, that's like mostly what I'm doing here at
Yeah.
MIT.
So when you came up with this idea, were you building off of someone else who was already researching and building these, or is it kind of something you started?
Yes. So it's actually this project was started by my advisor. So like this is like he had this ideas of like using what we call the artificial muscle to actually cause this flapping motion. Because like you kind of it's like human beings, like you need to have like muscle like contract or elongate to have any type of motion. And then my advisor was the person who come up with this idea. It's like, oh, we implement one of those artificial muscle and try to do this flapping motion. So he's the one who started it. My job is more like to improve, like, let's say, the efficiency or like the performance of this robot. And also, like, we try to think of like different applications or capability that this robot can achieve. So, for example, one of the capability that we tried to achieve in the past was like we can actually let this robot light up. So basically, we put some like um electroluminescent particle inside the artificial muscle. So whenever you try to flap your wing, you can actually shine light. So it's basically like a firefly. So you can actually, light up your surrounding area, or you can be used for some of the tracking uh, application in the industry.
Yeah. So one question I have is when you're doing your PhD, is the end goal basically to have a paper written about your research?
Yes. So I think I I would say the abstract goal is to usually you want to like achieve something. You want to push the boundary of whatever engineering that you're working on. For example, in my case, it's a robot. So I want to kind of like push the boundary um of this platform, like see how far it can go in terms of like performance or capability. And but like along the way, if you have like some incremental improvement, or like if you accumulate this like incremental improvement, you get to actually publish a paper along the way. So I think publishing paper is like a really big goal that you kind of like share your advances that you have made in the past. I don't know, could be a couple months or a couple years with the entire field. So you kind of like you're sharing this knowledge with the entire field. That's I think the reason that people publish paper. But like to me, I think I'm like more looking towards like how far like our robot can can go, or like how much our robot can do. And publishing paper is just like one of the intermediate goal. It's just like along the way we try to share this information with the field, so like other people in the field can be able to uh, use them as well, use the knowledge or like use the experience that we have obtained.
Yeah.
Yeah.
Wait, so for your PhD, what's the
Mm.
specific thing that you're trying to improve with these robots?
Um, One thing that is really interesting is so one of the problem when I first joined the lab, one of the problem with this robot is that it has really limited lifetime. So this robot, like we need to kind of like need to assemble them or fabricate them manually. So it usually takes us like a month to do just one robot. Like me working full time for a month to do one robot. But then this robot has only 20 seconds of lifetime. So it's like, if you just have like one product and that will only last 20 seconds and then it break, like nobody gonna buy it, right? And nobody gonna actually put it into the field to do any like real world application. So one of my first project was to think about like how can we prolong the lifetime of the robot. I think like, we can still spend like, a month or like 2 months building one robot manually, but hopefully this robot can actually last longer, like at the very least last like longer than 20 seconds, basically. So I made a few changes with my colleagues, and then we tried different type of materials, different type of design. And then I think recently we got to the point where our robot can operate for like more than 2000 seconds. So basically, there's like 100 times improvement. So that's kind of
Yeah.
like one of the topic that I have been working on is like to improve the lifetime of the robot.
Wait, so when the robot's lifetime ends, that just means the battery dies?
It means the mechanical part breaks.
Oh,
So yeah. So there's kind of like a linkage. Like when you do this flapping motion, there is actually a linkage that does this. And this there will be like one type of material that allows you to do this. It's like imagine like there's like paper that does this to cause the flapping motion. And in the past, it's like after 20 seconds, this paper just like been torn off entirely. So like we actually optimize the geometry of the papers and we tune a lot of like different parameters. So like nowadays it's like the that linkage won't be torn off basically. So
Yeah.
it's a mechanical part that like kind of fell. Yeah, it's basically you can imagine it's like something that breaks. It's not the battery.
Yeah. So what are your future plans? What do you want to do after your PhD?
That's a good questions. I think I'm still deciding in between like whether I'm gonna work as a engineer in a company or I'm gonna be a professor in academia, basically. So I think this is like a question like a lot of like PhD think about. It's like, oh, you can either be an engineer or like be a research scientist in a company, or you can be a professor. I'm still like thinking about this. So I don't really have like a good answer uh for this question now.
Yeah. Are there any industry jobs that you'd be able to work on similar things as you're doing now?
I think what we are doing in our lab is relatively new, and they are very, very limited like labs or like researchers around the world that are doing similar things. So like
Mhm.
I think currently there are no company, at least not that I know of. There are pretty much like no company that is doing what I'm doing. So I think there won't be a really one-to-one matching to my expertise. But I think in my past experience, it's like you probably don't it's really hard for people to like find a like a one-to-one matching job. But you can
Yeah.
actually use some of the transferable skill that you learn uh, doing your PhD or doing your study in general to work on some different things. Because a lot of like the science or like the engineering, they're they have like a lot in common. So if you really understand one thing deeply, you can actually apply those knowledge in a different domain, if that makes sense.
Yeah.
I think like the physics or like the math of like how let's say something if I just like um, throw something in the air, this physics doesn't change. So like if I throw something else in the air, this will still be similar. And if you have the knowledge of analyzing one thing, you will have the knowledge of like analyzing this another like 100 things as well. So you can actually grab what you learned in the past and apply to a new domain, basically.
So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you.
Um, I think my biggest advice will be probably not like follow the exact same path as me because like I feel like everybody is like different. So, but like my advice would be like um I think when you're young, you should try as many things as possible. As in like try as many different discipline as possible. So like a lot of time you might be like it could be like good at math, good at physics, and but there are a lot of like engineering like subject there. Like you can either do like nuclear engineering, you can do like engineerings or other things. I think don't limit yourself to just one discipline because it's like currently popular or because it's like easy to find a job. Try to just try a variety of things and find one or two that interests you the most. That you feel like, oh, when I get up this morning, I really want to do this. I really want to, explore more about this. I really want to read this paper about this discipline. And I think you really need to try to find a discipline that you are really passionate about. That's the things that will drive you like further. Because I think studying is like a really long process. Like, college is like 4 years. If you do a master, it could be another one or two. If you really want to do a PhD, that would be like 4, 5, 6 years. So it's like a 10-year period of like studying. If you don't work on something that you're interested in, you might just burn out along the way. So I think my advice would be like try to find something that you are really interested in and re do try a variety of things before you decide which way where you want to go to.
All right then. Thank you for joining me on the podcast today.
Mhm. Yeah. Thank you so much. Thank you for having me.